Welcome all. Let us see today how we can process Cartosat stereo pair with the help of Leica photogrammetry suite module, and how we can prepare a DEM from Cartosat stereo pair through LPS. I have a stereo pair open in GLT viewer. Let us see the alignment of the stereo pair. It's of one is band A scene, another is band F scene. Now this is the LPS window. So let me reopen it again. Now this is the LPS icon. Once I click, I'll have a LPS project manager window. The first job is to create a new block file. For that, file, new. I have a specified output folder. Here I'll be creating all of my outputs. The block file extension is .blk. So it will ask the geometric model property of the block. Now it can be of camera, polynomial based push broom, orbital push broom. In our case, that is for Cartosat data, we'll be using rational functions. Now in rational function we have something called Cartosat RPC. So once I choose this, there is a block property setup dialog box. Here I can set my desired horizontal and vertical datum. Now the default is geographic lat long and WGS 84. So I'm going with this. Now if I have some projection file saved somewhere, I can import that projection file. And another LSR is for unknown projection, where projection parameters are unknown. It is mainly used for a small area. So now once I say OK, my block is ready, but the block is empty, so I have to add my images to the block. So let me first add this one, band A image, then this is band F image, so this is my band A and band F image added in the LPS project manager, rather added in the block. Now there is some process flow. I can see this portion. First is active, so both the images are active. Next is pyramid layer. These two boxes are green, means pyramid layer is generated for both of the images. Now interior and int and ext means the interior and exterior orientation. These two are red for all of my images, means that interior and exterior orientation is not being performed. Then DTM and ortho, even DEM is also not generated from the image, and orthophoto has not also been generated. So these are the process flow we'll be seeing. Now before that, let us view some of the important icons. Now this is a point measurement tool where we'll be calculating the where we'll be measuring the points, and it is useful for giving the GCPs and calculating the type points. Then this is the automatic type point tool, this is the triangulation tool, this is the DTM extraction tool. Now once if I extract a raster DEM, then it cannot be edited. If I extract some, say, LTF or Tera model tin, this kind of DTM, then I can edit some of the DTM points. So this icon is for DTM editing. Now this is ortho resampling process for orthophoto generation. This is ortho mosaicing process, and this is stereo feature collection. So now we have actually two types of stereo feature collecting tool. One is like a stereo analyst, and another is LPS Pro 600 and microstation combination. So these are the few workflows, and let us see how we can orient the image internally and externally using RPC files, and how we can triangulate using GCPs and automatic, with the help of automatic type points, and how we generate the DEM and orthophoto. Now let us perform the interior and exterior orientation with the help of RPC file provided with the satellite image. Now once you click here, since all the path recorded, since the path of the image is recorded here in the block file, so automatically the path of RPC is taken here, band A RPC. If I click on this next button, I have band F RPC. So once I say OK, so now interior and exterior orientation is automatically done using this RPC file. Now our next job is to create some type points. If we have GCPs, we have to first input the GCPs. Based on that, we'll run the type point operation, type point generation operation. Then on the basis of those type points and GCPs, we'll have to triangulate this stereo pair. Now this tool will help me to generate the type points. Here I have two options, one is stereo type point measurement tool, another is classic. So I'll be going with classic. Now type point measurement window looks like this. Now this is the overview of the image. This is a particular area zoomed in, and this is a particular feature of the image where we can see in this small window. Now we have automatic type point properties. Before that, before I generate this automatic type point property, if I have some ground control points, then I can create some GCPs here with height, and on the basis of those ground control points, I'll generate rest automatic type points. So that is much preferable, and that will be more accurate. To do that, if I say add, there will be one row added. Now type, how I am using that ground control point. If it is full, then I have X, Y and Z for the corresponding GCP. If I have only X and Y, then I have to choose the horizontal type. If I have only Z values, then I'll choose as vertical. Now this way I have to add GCPs, and on the basis of that GCP I can generate the automatic type. Now in my case, since I don't have sufficient number of GCPs, so I'll be going with automatic type point. Now I'll say delete selection. Now I'll go with this automatic type properties. Actually, to generate the type points, the initial type will be always of exterior header or GCP, because exterior header of GCP means here it will be using the RPC file, so from there it will generate the automatic type points. The main purpose of the type points is to tie these two images. Now if I require to define some of my custom pattern for the type points, then I can define it like that. Whether how it will be distributed, I can define like this. So it will be densified, in this case densified rows, densified columns, like that. Now if I like this pattern and say OK, so software will try to generate the type points in this pattern. Now if somehow I'm not able to get the desired number of type points or good number of type points, then I can manipulate this parameter for starting column, starting line, column increment and line increment. So anyway, once I have this automatic type point generation properties, I'll say run. So it's running. Here I can see the progress bar. So now I have a type point report, actually in form of a cell array, number of intended point. I have chosen the default distribution. So as per the default distribution goes, number of intended point was 25, number of point found is 31, and number of patterns is 25. So basically number of point found is 31 and intended point was 25, so there is a success rate of 100%. So now here I can choose among this 31 number of point. I can cross check individual point. Just select on the cell array, cell number, click on the cell number, identify individual places here, and you can see a zoom view here whether the type points are generated at exact positions or not. Since I told you that already I have shown that the image is having almost 100% overlap in my particular case, so always there should be a similar place where type point is generated in case of left image and right image. Now any arbitrary point you can just cross check whether it's the same point or not, same feature or not. Now once I am satisfied with the pattern of the type point, so this is the time to triangulate the image. Here I'll have the triangulation error. Now I'll go for refinement with polynomials. I'll go with polynomial order 1 and I'll say run. Now here I can see my RMSE is 1.21. now RMSE is so high because I don't have any GCPs. Now if I have a good number of GCP, say 50 number of GCP, so I can use maybe 30 as a ground control point at the first of triangulation. Now after seeing this error, if it's still so high, then again I can add some GCPs, and on the basis of that I can regenerate the automatic ties, and again I can triangulate. So if this is basically an iterative process, and this way error may go down to some extent. Now once it is well within my level of acceptance, I'll say accept. Now once I say accept, now I have my X reference, Y reference and Z reference. In my case, all X, Y and Z references are purely based on automatic type point. So once I have triangulated this image. I got this X reference, Y reference and Z reference. Then I'll say save, and now close. So in this LPS project manager window, I can see all the positions of this tie points what I have generated. Now my stereo pair is triangulated, so I have work left is for Dtm generation and orthophoto generation. So I can go from here also. If I click on this red box just below the Dtm, then I'll have Dtm extraction dialog. Here I'll have few options like DEM, Terra Model Tin, 3D Shape, ASCII and LTF. Now this DEM is basically raster DEM, the Terra Model Tin, 3D Shape, LTF, these are all basically it's a tin format. Now if I need to edit my DEM in some cases, then I have to generate maybe in 3D shape file, Terra Model Tin or LTF. Now output file, if I have my desired folder, here I'll generate my output file. It will be in .img format. Now I can create a square pixel DEM. Unit will be in meters. So now here in these segments, LPS is using one global DEM which will provide a tentative idea about the range of the DEM which we are going to prepare now. Now another important thing is there in the option advanced properties. If I go to accuracy, then I can use any say block tie point, which is a good tie point, or maybe any external DEM as a reference to just to improve the accuracy, height accuracy of my DEM what I am going to create. So now when it is all done, my job is to say now run. So now we can see that the red box is just under the DTM column is green. Now it means the DTM is generated. Now the left folder panel, here we have the DTM folder. So once I click here, I have band F DTM. So from here we can view the DEM. If I say right click, then view the prepared DEM will open in a GLT viewer, a normal viewer. So here is my DEM. Now how the DEM has created, just to verify it, we can go and open the virtual GIS. The speckles what we can see is of C. This portion, this entire portion is C. So in LPS we have an option to create a AOI inside the area inside the AOI will not be present while creating the DEM. So now what we can go for a target, and let us zoom out a little. Increase the exaggeration a little to have a better view of the elevation. So this entire portion is C, and this is the terrain. Now the last and final process is creation of orthophoto. So once I click on this red icon, the ortho resampling dialog will come up. Here I have the TIFF file name, which is a band A TIFF. Output file name will be ortho band A img. Now I can change it. I can create a TIFF also. So this is for ortho band A. Now I can go on adding here. This is for band A. If I go for band F, then I'll say it is band F ortho. So these two are the file names. So I can see 2 is added. Now if I look at the advanced the resampling process, if required we can take it as nearest neighbor. Now ignore zeros. If I want to change the projection of this orthophoto, then I can reset the projection from here. Now I'll say, and if I have multiple images to produce ortho, then I can go for a batch as well. Here batch option is available, so I'll say okay. Now the first one is resampling for band A file to my output file name as ortho band F. Now here I can see once the process has started, the red boxes below the ortho column are already green, so it means that all my process flow is complete. Now it is creating the orthophoto for band F from the parent image band F TIFF to my desired output file. Now once this process flow is over, then the only process left is for stereo feature collection. So here we can see now the two ortho, band A ortho and band F ortho, is already prepared. So let us view these images. So this is my band A ortho, and on top of this file I'll open this bandf ortho. Not this one. Now I'll go for swiping. So this one is ortho rectified band A and band F image. So let us open a GLT viewer and see what is the difference between the original band A band F image and what is the difference between these two orthophoto. Left is the orthophoto and on the right viewer I am opening so this is my original image and this is my orthophoto. So if I go for swiping, clearly I can view the shift or rather terrain tilt on the right image, and if I go for a swiping on my left viewer, so I can see there is a very less tilt due to ortho rectification technique. So this is the basic utility for ortho rectification. Now once I create the orthophoto, this is useful for stereo feature collection. Now in LPS, the stereo feature collection application, this is stereo analyst for imagine is one, and another will be the Pro 600 and MicroStation combination. So these two might be the combinations. So when we select this one and say OK, so I have my, actually it will fetch the block file. So in block file also image information, image path is stored, so everything will be opened. My stereo pair will open inside the stereo window. Here I can, if I zoom into a particular area, so I can adjust the respective parallax. With stereo specs, I can zoom into a particular feature, maybe a building or a road. And now if I go for a new stereo analyst feature project, so I can select my feature of interest, what I am going to create, maybe building, maybe some boundaries, coastal features. So based on selected feature, I can create a 3D, maybe building, maybe road. There are various tools to create these kind of features. So basically this is an overview how we can process a Cartosat data and how we can collect, what are the ways to collect stereo features, and what is the utility to create a block, and what is the utility for orthophoto with the entire process flow of LPS. So I thank you all for your patience. Thanks.